All right, so once again, review 6.1-4, we're going to do number 8. So number 8 is about an arrow being fired up into the air. So you should be picturing an arrow being fired, oh no, an arrow being fired up into the air. All right, so the problem tells you the mass of the arrow. It tells you that the mass is 0.75 kilograms. It tells you the spring constant of the bow and arrow is 1,200 newtons per meter. And it tells you that he stretches this thing back 0.8 meters. Okay, so notice between here and here it moves down a little bit, right? So when I release it, it's going to go back up that same little bit, isn't it? All right? So when you do these conservation of energy problems, in my mind, the most important thing is identifying the important points in the motion. And at each important point, you need to be thinking about height, because it determines GPE, velocity, because it determines KE, and x, how far you stretch the thing, because that determines your EPE. Good? So, in this one, we stretch the thing back 0.8 meters. And the question wants to know what the velocity is when the arrow leaves the bow and arrow. So, you can make drawings one of two ways. You can either do like little snapshots in time. So here's, whoops. So here's point A with the arrow. And then here's point B with the arrow. And then here's point C with the arrow. Cool? Or, if you prefer, I saw some people just draw this. They said, all right, well, here's the arrow before I fire it. Here's the arrow coming out of the bow. Here's the arrow at the top of its path. Point A, point B, point C. Follow? All right, so I don't care which drawing you make, but you should be, at the very least, thinking about one of those drawings. Now, at each of those points, I need to be thinking about height, velocity, and displacement. So I always choose the lowest point in my problem to be a height of 0. So height, oops. So in this first part, in part A, my height is 0. What's the velocity there, you guys? 0, right? But we stretched this thing back 0.8 meters, right? Okay. Now question A wants to know what's the velocity here when it leaves the thing. So, is my height here still 0, you guys? No, because between here and here it moves up, right? So what's the height? 0.8, right? Good? And what's x now? 0, right? So are there questiones with what I've done so far? All right, so let's solve this thing. So here we go. It should be true that the total energy at point A is equal to the total energy at point B, because the only two forces are gravity and the spring, and those are conservative. So at point A, what kind of energy do I have, you guys? Just elastic, right? Because these guys are both 0. So the elastic potential energy at A has got to equal at point B. What kinds of energy do I have? GPE and KE. Good? All right, so my elastic potential energy, that's 1/2 K times X, don't forget to square it, equals the mass times 9.8 times the height plus 1/2 the mass times v squared. Good? And then solve it. And hopefully that gives you the answer that's on the sheet. Does it? Okay. 31.8 meters a second, right? Okay, so the answer on the sheet was correct, despite some initial confusion. Everybody good? Are there any problems with what I did there? Okay. The next question wants to know how high it goes. So now we're talking up about point C, right? So at point C, what type of energy do we have, you guys? All GPE, right? And what should be true about that total energy? What should be true about that GPE? Should be the same as it was in A and B, right? So to do the last one, I'm just going to go, oh, well, the elastic potential energy at A, because that was my total energy, has got to equal my GPE at point C. And solve it. Right? Because all of my energy at point C is GPE. So you get 1/2 times 1200 times 0.8 squared equals the mass times 9.8 times the height, and solve for the height. Good? Any problems? All right. So that's number 8. Does anybody have any questions? You guys are creeping me out by how quiet you are. We're good? All right. Number 9. So number 9 says, let's do it again. This time, instead of firing the arrow, I don't know what the actual arrow for this thing is. Instead of firing the arrow straight up into the air, we're going to fire it at an angle. So we're still going to stretch it back 0.8 meters. Is the height when it comes out going to be 0.8 meters? No, it's going to be smaller than that, right? Does that make sense? Yep, well, so in this one, we fired it straight up in the air, right? So, oh, dang it. That was good, I didn't swear. So in this one, we pulled it back 0.8, right? I don't know who said, can you explain that? Yeah, okay. So in this one, we pulled it back 0.8. So when we release it, it's going to go up 0.8 between drawings A and B, right? Okay, in this one, in number 9, what's going to happen is we're going to still pull it back 0.8 meters, but it's at a weird angle. So I'm still pulling back 0.8 meters. So when I let it go, is it still going up vertically 0.8 meters?
Oh, no.
Do you see what I'm saying? So basically what we're doing is we're taking this and we're tilting it at a 30-degree angle. So here is my drawing for number 9. So there's point A, which is when you've got the arrow pulled all the way back. So your height is 0, your velocity is 0. The thing is pulled back 0.8 meters. And then ka-chunk, you let go of it, and it's released here at point B. Does everybody see what I'm doing there? So this drawing is like this drawing over here, right? Okay, and so at that point, let's see. My height is no longer 0. We're trying to find the velocity here. How far is my slingshot thingy stretched now? 0, right? But to solve this thing, we got to know the height at this point. And so the idea is the hypotenuse of this triangle is 0.8 meters. We know we're firing it at an angle of 30 degrees. So I think we can do some simple trig to find this height here, can't we? Does that make sense? So instead of moving straight up 0.8 meters, it's moving 0.8 meters at this weird angle. Cool? And so do a little bit of trig, and this height turns out to be 0.4 meters. Abby, are you good?
Yep.
Is everybody good? Is anybody ungood? Good. That's not a word. Do I have any coffee? A little bit. All right, so now we can solve this thing. So Now it's basically the same thing we just did, right? Total energy at A has got to equal the total energy at B. So the total energy at A is all the EPE, so 1/2 times 1200 times 0.8 squared, equals, at point B, we've got GPE dependent on this height instead of 0.8, right? So 0.75 is the mass, 9.8 is the acceleration of gravity, 0.4 is our new height, plus 1/2 the mass times V squared, and solve for V. Hopefully that gives you the answer that's on the sheet of 31.9 meters per second. Good. All right, and then part B, I'm going to say don't worry about. Again, that's another one where if there's more time, I'd go over it. You got to use some projectile stuff because the velocity at the top isn't 0 because it's being fired at a weird angle. But with the snow day, I think we're going to not worry about that one. Good? All right. Any questions on 8 or 9? All right then.